Hello learners, and welcome to today's lesson of interpreting graphs. Now, to begin off our lesson, let's start with a did you know? So, did you know that graphs are mathematical stories? With a graph, a farmer is able to represent the story of the water pumped on his farm. He's able to show water levels in a tank at different intervals. He's also able to show when the water pumping started, how long it took, how much water was collected, and what was the rate at which the water was collected. And as we can see from that graph there below, we have the water levels in kiloliters, and then it is showing how long with the hours there each of those tanks were filled. Isn't that interesting? Let's move on to our lesson objectives. So by the end of this lesson, learners will be able to, you will know the features of graphs with special focus on the following features of linear graphs. That is the gradient and the y-intercept. So looking at our concept map for today's lesson, we have our topic, which is interpreting graphs. Then we are going to be looking at linear graphs, where we are going to be looking at increasing graphs and decreasing graphs. Then next we are going to be looking at the gradient, where we are going to be defining the gradient and then also determining the gradient. And lastly, we are going to be looking at intercepts, where we are only going to focus on the y-intercept. So for this lesson, you should be able to write down ordered pairs from a table, plot ordered pairs or coordinates on a Cartesian plane, sketch a line from plotted coordinates, describe data as continuous or discrete, interpret graphs that show trends, and identify where a graph is increasing or decreasing. Let's look at that pre-knowledge practice. So we have the following table, or we've been given the following table, and it says there, write down the data in the following table as ordered pairs. So now if you remember, ordered pairs are written in the form of the x value, and then we use a semicolon and we write the y value. So in our table here, we can see that we have the input values, which are the x values there, and then we also have the output values, which are the y values there. And each of those pairs we are going to write down as ordered pairs. So let's start with the first one there. As we can see, the x value is a -3, and the y value is a -5, and that would be the ordered pair there. Let's move on to the next one. So the next one here would be a -1 as the x value, and as the y value we have a 3. Moving on to this pair over here, we have a 0 for the x value and a 4 for the y value. Then we move on to the next one, where we have 2 as the x value and -7 as the y value. And lastly, we have our last pair, which is 5 as the input, and we have 3 as the output. So all of these points, or this table, has now been written as ordered pairs there, where we know that the x value comes first and then the y value is the one that follows. Then the next one here says, the next practice here says, show where the points A to E lie on the Cartesian plane. So we have been given a couple of points here from A up until E, and we are supposed to show where these points lie on the Cartesian plane. Let's start with the first one there, which is a -3 and a -5. So we know that the -3 is the x value and the -5 is the y value. So we will go to -3 with the x values, and we will move down to -5 for the y values, and that will be our point A. We move on to point B, which is a -1 and a 3. So x is -1, well, then we are going to move up to 3 for the y value, and that is our point B. Looking at the next one there, it is C, 0 as the x value and 4 as the y value. So that means that point is going to be on the y-axis there, and that is point C. Then we are going to have D, which is 2 and -7. So the x value is a +2, and the y value we are going to move down to a -7. As we can see there, our y values, they end at -6, so we are just going to add a -7 there so that we know where we are placing our ordered pair. So it is 2 for the x values, and we are going to move down to a -7 for the y values, so that is our D. And lastly, we have our E, which is a +2, and then we have a 3, a +3 for the y values, and that is our point E. So those are all the points there shown on the Cartesian plane, just to remind you of how we place our coordinates on the Cartesian plane. Now we are going to be looking at interpreting different graphs, where we can see there Sheila owns a honey farm that supplies stores with honey. The table below shows how much honey is made depending on the number of workers. The amount of honey made is measured by jars filled. So as we can see there, we have the number of workers, and then we have the jars filled. So if we have 1 worker, then we have 1 1/4 jars filled. And when we have 2 workers, then we have 2 1/2 jars filled. So that is how it works over there. So here we want to remind you of discrete and continuous data. So remember that continuous data is quantities or variables that can include fractions. These are obtained through measuring. So looking at the table, which one do you think is the continuous data? Now, if you are thinking of the jars filled, then you are absolutely correct, because now this data can include fractions. And as we can see, when we think about a jar, it can be filled 1 full jar and the next jar be filled just 1/4 of it, which is what we have in our table when we have 1 worker. Then when we're looking at discrete data, that is now the quantities obtained by counting. Only consists of whole numbers. Now, what could we be talking about here? We are talking about the number of workers. Now, if we are looking at the number of workers, these are quantities that can only be counted. Now, we cannot find a person that we say is 1/2 of a person. We are talking about whole numbers only. It is 1 person, it is 3 people, but we cannot find 3 1/4 of a person. So that is what we are talking about when we say discrete data. So the next pre-knowledge practice here gives us a graph. So it says the graph shows the number of cars that a company sold starting from the end of July 2022 to the end of December 2022. And as we can see there, we have the car sales for 2022 from July up until December. And as we can see there, for example, in July, the cars that were sold were 25 cars. But if we look at October over there, the cars that were sold were 35 cars. So that is just to remind you how these graphs work. But let's look at the following questions for this graph. So which month sold the least number of cars? So that means that we need to look at our graph and look at where the least number of cars were sold. And now the dot that is the least number of cars we can see there is in September. So September is the one that sold the least number of cars. Then when we're looking at the next question there, which month sold the highest number of cars? So now we are looking at the month that has the highest number. And in this case, as we can see there, it will be December, because we can see that in December, 45 cars were sold. The next question there says, how many cars were sold in November? So that means we need to go to November, go up to November and see how many cars were sold. And if we follow that graph there, we can see that it is 30 cars that were sold in November. Then we have during which months did the sales decrease? So now we are looking at where there was a decline, or where our dotted line there is going down. So during which months did the sales decrease? So since as well this was the end of July, we can see there was an increase to the end of August. But when we're looking at August to September, we can see that there is a drop there. So we can say that during September there was a drop. But is that the only drop that is there? We can see that in October it went up, but again from October to November. So we know that during November, those sales, they did go down again. So the months where the sales decreased, that was in September and in November. Let's now look at some keywords that we are going to be using during this lesson. So we have there a linear graph. This is a straight line graph defined by the equation ax plus by plus c is equals to 0, which may also be written as y is equals to mx plus c. Then we have gradient, which is an inclination, a slant, or the slope of a line. Then we have the y-intercept, which is the point where a graph crosses or intersects with the y-axis. And those are going to be the keywords that we are going to be working with during this lesson. Let's quickly go to an ad break so we continue with the rest of our lesson.